Physics Part 96. Momentum and impulse. It is now useful to introduce a quantity called impulse and relate it to a change in momentum. If a constant force F acts on a body for a time delta t, the impulse of the force is given by force delta t. The unit of impulse is given by the unit of force, the Newton, multiplied by the unit of time. The second, it is the Newton second, Newton per second, NS. We know from Newton's second law that the force acting on a body is equal to the rate of change of momentum of the body. We have already expressed this as the equation F is equal to delta P divided by delta T. If we multiply both sides of this equation by delta T, we obtain F delta T, which is equal to delta P. We have already defined F delta T as the impulse of the force. The right-hand side of the equation, delta P, is the change in the momentum of the body. So Newton's second law tells us that the impulse of a force is equal to the change in momentum. It is useful for dealing with the forces that act over a short interval of time. As in a collision, the forces between colliding bodies are seldom constant throughout the collision, but the equation can be applied to obtain information about the average force acting. Note that the idea of impulse explains why there is an alternative unit for momentum. We introduce kilogram meter per second and Newton per second as possible units for momentum. The kilogram meter per second is the logical unit, the ones you arrive at if you take momentum as being the product of the mass and the velocity. I beg your pardon, please. The Newton per second comes from the impulse momentum equation. It is the unit of impulse, and because the impulse is equal to the change of momentum, it is also a unit for momentum. Example, some tennis players can serve the ball at a speed of 55 meters per second. The tennis ball has a mass of 60 grams, and in an experiment it is determined that the ball is in contact with the racket for 25 ms during the serve. Calculate the average force exerted by the racket on a ball. The change in momentum of the ball is as a result of the serve is 0.060 into 55, which is equal to 3.3 kilogram meter per second. By the impulse momentum equation, the change in momentum is equal to the impulse of the force. Since impulse is the product of force and time, Ft is equal to 3.3 Newton per second. Here t is 0.025 seconds, thus F is equal to 3.3 divided by 0.025, which is equal to 132 newtons. Now it's your turn. A golfer has a ball of mass 45 grams at a speed of 40 meters per second. The golf club is in contact with the ball for 3 ms. Calculate the average force exerted by the club on the ball. Elastic and inelastic collisions. Elastic and inelastic collisions. In some collisions, kinetic energy is conserved as well as momentum. By the conservation of kinetic energy, we mean that the total kinetic energy of the colliding bodies before collision is the same as the total kinetic energy afterwards.